Okay, welcome to the IETF Track. Thank you for joining us. My name is Alissa Cooper, and I'm the chair of the Internet Engineering Task Force, the IETF. The way that we're going to run this session today is that we have a series of talks about different aspects of the IETF. I'm going to start off with an introduction to the IETF, talk about what it is and what it does, and how you can participate. And then I'm going to hand it off to Job Snyders, who's going to talk about his experience as an IETF participant. Then we're going to hear from Ignas Bagdonas. He's going to talk about the operations and management and manageability work in the IETF, as well as routing work in the IETF. We're going to have Ron Bonica, who's exiting stage left to go get his microphone. He's going to talk about IP layer networking. And we're going to conclude with Tail, who's going to talk to us about DNS work going on in the IETF. We really want this to be an interactive track. It's a long period of time that we have. And so we would invite people to come up to the microphones whenever you have a question. Interrupt the speaker if you need to. You don't need to save your questions for the end. So the mission of the IETF is to make the internet work better. If it works better today than it has in other times in your life, you can say a little bit of thank you to the IETF. If it works worse today than it has other times in your life, the IETF probably also had something to do with that. So come talk to us and tell us how we can fix it. Can I see a show of hands? Who knows what the IETF is? Okay. I like to ask a question at the beginning whereby by the end of the talk, every single hand would go up, 100% information shared. But it looks like we have some knowledge about the IETF already in the room, which is great. The IETF is a large community of internet engineers, designers, developers, researchers, network operators, and others who come together to produce open standards through open processes. It's the premier internet standards organization. It's an organization that's over 30 years old. So what is it that the IETF does? The lifeblood of the IETF, our currency, is specifications. What we do is we produce documents, and those documents are called RFCs. RFC stands for Request for Comment. There's been about 8,600 RFCs published over the course of the existence of the IETF, and actually even dating prior to the IETF itself. So even those who aren't strictly speaking familiar with the IETF have probably heard the term RFC. Maybe you've heard of RFC 1918. There's some that are extremely well known out there in the community, RFC 6811 for RPKI. These are our main output. And there's lots of different kinds of RFCs. So many of them just have a number like 6811. But sometimes we produce standards documents which are protocol specific, where we're specifying a particular piece of technology or an extension to an existing protocol, that sort of thing. Sometimes we're producing informational documents that describe some aspect of a protocol mechanism or some dynamic about how you make use of a protocol. And sometimes we specify what are known as best current practices, or BCPs. So BCP 38, probably very well known to most of you, is one such document. There's in the neighborhood of 100 BCPs. And this is when we write down what we think collectively as a community is what the best known current practice is, or the best way to do something, the best way to operate a particular protocol. So there's a bunch of different flavors of these, but understanding RFC and BCP is pretty key. The technical work of the IETF is broken down into 6 different areas, and we're going to cover in detail several of the areas that are most relevant for network operators. That's what the rest of the panel up here is going to cover today, but I'll just go over them briefly. So in the internet area, this is where we focus on packet networking and addressing. This is the area that has produced IPv4 and v6, also DNS and DHCP, although the DNS work now kind of exists in lots of different IETF areas. And also some of the adaptation layers for Internet of Things, 6LoWPAN and LPWAN. These are all just examples. There's many, many more protocols that get produced in each IETF area. The routing area is where we focus on getting the packets to their destination. How do they get there? How are they forwarded? How are they routed? So BGP, OSPF, ISIS, MPLS, pseudowires, and then some of the newer work includes service function chaining, network virtualization overlays, deterministic networking, those kinds of things. The operations and management areas where we look at, okay, we have this protocol stack. How do we operate it? How do we configure these things? How do we manage them once they're deployed? So some of the older protocols, IPv6 and SNMP. Some of the more recent ones include Yang, both the language and many of the models, netcont for configuring them, and the AAA protocols. In the transport areas where we focus on the end-to-end experience, layer 4 primarily, TCP, UDP, going back through the decades, and our current big project in the transport area is QUIC. And the applications in real-time area is where we focus on everything application related. So web protocols, email protocols, real-time protocols, as well as primitives like the URI specification, for example, comes from the applications area. That's actually my personal native area, so all this weird routing and internet and operation stuff is, I'm still learning. And then finally, we have the security area where we produce security primitives and protocols that are used kind of up and down the stack. So things like TLS and IPsec, as well as EAP and PKIX, lots of different stuff going on there, and a growing body of work in the security area. We don't have that one represented today, but it's pretty important in terms of the IETF's focus now. So how can you participate in the IETF? There's actually many different ways, and the barriers to entry are very, very low. So anyone can participate in the IETF. There is no membership. It is all individual based. So if you have an interest, like something that you've heard about, that you want to learn more about, that you want to contribute to, you have a little time on your hands, you feel like doing it as a hobby, or you have employer support and your company thinks this is really important, you can participate. We don't turn anybody away. We run through an open process. We do almost everything in public. So there's no, secret closed rooms. It's open to all. And we operate in a kind of voluntary mode. So we're intending to produce specifications on a consensus and voluntary basis where we write something, we get the consensus of the community, we put it out there into the world, and we hope that people will use it if it makes the internet work better. We can't make anybody use our specifications. We don't do any kind of mandates or policing. And we certainly can't make them use them in specific ways. It's just work that we put out into the world in the hopes that it helps improve interoperability on the network. So how can you get involved if you wanted to get involved? The easiest way is to join mailing lists. All of those areas that we looked at on the previous slide, there's about 115 or so working groups spread across those areas. And each of those working groups has its own mailing list. So if you're really interested in BGP or you're really interested in routing operations, you can join the relevant mailing list, take a look, see what people are talking about, join the conversation if you have something to offer. That's really like the easiest path to just kind of get a sense of what is it that people do in the IETF. Bumping up a little bit in level of effort, you can review drafts. So drafts, or internet drafts as we call them, this is how people formalize their ideas when they're trying to instigate conversation or eventually publish an actual RFC. You write a draft. So people will share many hundreds of drafts every year with different working groups or with their colleagues, and those are basically the subject of the conversation within the IETF. So you can review what other people have done, you can offer comments, you can ask questions, you can provide input if you think there's a better way to do something that you see somebody trying to specify. You can write code. Many people have probably heard of the motto, rough consensus and running code. Both of these are still very important to us in the IETF. I'll talk a little bit more about consensus in a minute. But having running code, whether it's a proof of concept or an actual implementation or a reference implementation, running interoperability tests with other people who are working in the same space as you, all of these things are extremely important to being able to develop good specifications. And we've put a lot of effort into cultivating a kind of feedback loop between developers and people who are writing code and the people who are writing the specifications, who sometimes are the same people, sometimes they're not the same people, but in either case, it's so valuable to get input from actually running something out there on the internet and at internet scale, if possible, and feeding that back into the design of the specifications. Writing code, contributing to our hackathons, which we host at every single IETF meeting, can be a great way to get involved, go and meet other people, see what they're working on, contribute to somebody else's project if you want to. It's a really good way to get involved. Speaking of the meetings, attending a meeting can also be a quite valuable part of the experience. So the IETF meets 3 times per year. We tend to rotate between North America, Europe, and Asia, so 1 meeting in each region per year. And this is a really nice way, if you have been participating on mailing lists or you've been following along, to go and meet people face-to-face, kind of like NaNog. See how people interact, get to know them, have some hallway conversations, and join the work of the IETF that's happening there. IETF meetings are very much working meetings, so there's not a lot of presentations like this one where I'm just blathering on at you from a stage. The objective usually is to further a specific set of work items that are present in each working group. And that's what we spend the week doing at an IETF meeting. And then lastly, you can author documents. Oh, you have a question, please.
Hi.
I can see you.
Ooh, it's loud. Hi, I'm Jared Motch from Akamai. Is it necessary for someone to attend a meeting to fully participate in the IETF?
Good question, Jared. Thank you. So it's not necessary, actually. Lots of people participate completely remotely, participating on mailing lists. We have a fantastic remote video and audio service that accompanies the meeting, so you can dial in, you can see everything that's going on, you can put yourself into the remote queue and have your audio and video be seen and heard in the meeting room. And it's absolutely not a requirement to ever attend a meeting. We have plenty of RFC authors who've gone all the way from being a complete newbie to having RFCs published and never came to an IETF meeting. So yeah, attendance at the meetings is optional. It's a useful, it's nice to see the people you work with if you can afford it, if you can manage it. It's useful sometimes for getting through some of the more difficult conversations that are hard to accelerate over email, but it's definitely not required. So authoring documents. This is sort of the penultimate thing or the ultimate thing that you can do in the IETF. If you have an idea, you're working on something, you identify a problem in your day job where you really feel like this protocol needs to be fixed, or there's some optimization that you think you can do that others would also benefit from. There's some piece missing, some building block that would allow you to interoperate better or more seamlessly or in a more performant way. You can write that down. You can get that published as an RFC if you can get the consensus of the IETF around it, and that's obviously a huge contribution from our perspective. So what would you do if you wanted to author an internet draft? There could have been many more than 6 steps, but I think there's really kind of 6 key ones in terms of just getting started. So the first thing is to write down your idea. As you can probably tell, we engage very much with the written word, everything in English, and being able to articulate your idea in writing so that you can share it with other people is absolutely the first step. The second step, and this is really, I think, the most important step of the entire process, is to talk to some other people about it. And my suggestion is talking to other people kind of quietly at first, so not necessarily taking something directly to a mailing list, unless you're feeling really confident, but talk to some of your colleagues, talk to some people at other companies who are working in the same space, get their feedback, see if they think this is something interesting that they would want to deploy, or that they agree with you or disagree with you about like what the best current practice is. Getting that kind of informal feedback at the beginning can really help you shape your idea such that it has a better chance of success once it gets out into the community. The other thing to keep in mind is that A lot of people who participate in the IETF have been doing so for a long time. The internet's been around for a long time. There's many ideas that have come up more than once and that have seen the light of day in the IETF and have not ultimately been standardized, or maybe they have. But by talking to people who are knowledgeable and who have been involved, you can kind of get a sense of whether the thing that you're proposing is actually novel, whether it's been considered before, what its history is, how it aligns to the existing documented internet architecture from the view of the IETF community. And that's super valuable feedback so that you don't end up suggesting something where there's already been a lot of ground trod in the past. On my last slide, I have some links that includes links to the contact information for all of the working group chairs. So this is a group of about 200 people who chair each of those individual working groups in the IETF. Those are really good people to reach out to when you have a new idea, to talk to them privately to kind of get a sense of whether the thing that you want to propose is likely to be of interest to the relevant working group. So talking to people is super important. Getting it into internet draft format. We have a specific format that we use for internet drafts. There's a bunch of tools that are available to help you depending on what your favorite tool chain is. But it has to go into this particular format in order for it to get posted to our repository, which is step 4, getting it posted to the IETF repository. That helps people be able to find it, and then it's documented, and you can start having a conversation on the relevant mailing list, step 5. So letting people know that this thing exists, opening it up to the world, essentially, for comment and review by sending it to the relevant mailing list. And then the last step is to nurture the draft and its discussion. So as I said, the IETF is a consensus-based organization, which means that we don't vote, but it also means that we don't rubber stamp. So what we do through our process is try to determine whether the set of the people who are participating feel that the thing that you've proposed is something that should be standardized. And to the extent that there may be objections to it or people who disagree with it, we try to get a sense of whether those objections can be accommodated, whether the protocol needs to change in order to accommodate them, or at a minimum, whether those objections have been raised and addressed before we move forward with standardization. And that whole process requires a lot of discussion. So if you want your idea to be standardized, you have to nurture that discussion. You have to stay on top of it and be responsive to people who are critical of your idea or those who support it. Really put energy into it such that it eventually gets to the end. It's not a short process usually to standardize something in the IETF. It takes a little bit of investment on the part of the authors. So the typical path to RFC, just to kind of give you a sense of that, the whole thing end to end. There's a few different ways that something can go from being an internet draft to an RFC, but this is kind of the most typical way. So let's say you've written something down, you have this idea, it's in internet draft format, you've shared it on the relevant mailing list, you've gotten some discussion going, and at some point in the working group, there will be a question put out, does the working group want to adopt your draft? And basically what this means is the working group committed to working on this thing through to the end? Like, is this something that we feel as a group we think should be taken forward? So that'll be a question, and then if it does get adopted, there will be a bunch more discussion within the working group before the consensus is judged within the working group. It's something that we call working group last call. So we go to working group last call, and there's a question of whether people want this, once it's in a much more mature state, to advance through to being a standard. And if that is successful, it moves on to a similar phase within the IETF community. So that's the point at which we judge the consensus of the whole community. We've talked about it a lot inside the working group, and now we're going to take it out to the whole community and say, we're going to issue a last call for comments to the IETF. This is a good opportunity for people who have other areas of expertise to provide their input and feedback. And this is like one of the really crucial and most valuable things about the IETF is that you get this cross-area review. You get people who are looking at a routing protocol, but they're security experts, and they look at it and they identify issues with it or ways that it can be improved that people with more of a routing background wouldn't necessarily have known about. Because of the broad swath of technology that the IETF works on, we tend to get that kind of feedback and improvement through the IETF last call process, and it all serves to make the protocols better. So we do that in the IETF community. We do a last call. If it appears that there's consensus to support the document moving forward, then it goes to kind of the finalization steps. There's a final approval step at the end with the Internet Engineering Steering Group, which is like a group of IETF leadership appointed by the community who do a final review of the document, raise any final questions and comments. And if those all get cleared through, then it heads off to the RFC editor, gets some copy editing, gets all of the placeholder values for protocol parameters and such get inserted into the document, and then out pops your RFC at the end. So as I said, a bunch of resources on the slides for people who want to learn more. We have a pretty well-developed newcomers program, lots of resources there about getting started, tutorials, videos, slide decks, the DAO of the IETF, which tries to tell you everything you would ever need to know. And as I said, the working group chair's contact information is up there too. So if you have an idea and you want someone to contact, obviously, if you're here today, you can come and talk to any of us. But if something strikes you later on, those people are good people to reach out to. So that is all that I had. Have a question?
Yes. Tony Tauber, Comcast. I don't know if I don't think you covered this, the different types of RFCs, and maybe that's worth talking about. I mean, I think a lot of people, I'll just put it out there, think of RFCs are like laws or something, and I think some expansion on what RFCs are, aren't, or maybe is probably helpful.
Sure, yeah. So I tried to elide this because it's so complicated. Yeah, so there's, in the most complicated version of this, there's 4 different streams and there's like 5 different types, and you can look at this matrix of streams and types, and it's all very confusing. But I think the important bits there are that sometimes we have the standards track. We call these confusingly proposed standards, but they're actually finalized documents on the standards track. So this is your protocol specifications, right? Then we have informational documents, which are not protocol specifications. They're informational. They are intended to provide information to the community. And yeah, okay. We have experimental protocols, which are very similar to standards track documents, except they're experimental and they are intended for experimentation such that eventually many of them, after some period of experimentation, are changed or improved somehow based on the data that's gathered in the experiment, and then they're updated to become standards track documents. And then I mentioned BCP, which is typically is a type of informational document, but has this special moniker that it's really considered to be the best current practice. So I think I hit the important ones. I'm not going to talk about the streams.
I think that this is good. I don't know if there's some rough idea of the relative quantity of each type.
There is. That's a good question. It exists on the RFC editor website. Yeah, I think it's more than half the documents are informational.
Right.
Yeah.
So, point being,
yeah,
they're not laws. They're useful and often important, and they've gone through a lot of processing to maybe express something that's more than just a person's opinion, hopefully. But just people should keep these things in mind, to get perspective on it, That's all. That was my thought.
Yeah, definitely. Can we do the back? They've been.
Hi, my name's Andrew Lee from Indiana University. Can you elaborate more? I'm going to hypothesize that not everyone who participates in IETF is an author. Can you elaborate more on the non-author roles? What do most of the people who go to IETF do, and how do they participate?
Sure, yeah. I think that intuition is right. It's certainly true that not everybody who comes is an author. I think there's a number of different roles. As I talked about earlier, I think this kind of process of review of, you start paying attention to some working group, you kind of learn the technology, or it's adjacent to something you're working on. So it's educational for you, and then also based on your experience, you can provide some feedback and you make the thing better. So there's a lot of reviewing that goes on, even among people who do not author. I do think some people come in order to kind of stay current, to like see what other people are proposing and kind of lurk and never offer too much feedback themselves, and that's a perfectly legitimate thing to do, and a nice way to learn what's going on out there. So there's that role. I think those are kind of the two main ways, I would say, that non-authors participate.
Thanks.
Yeah.
Doug Montgomery, I remember a couple of years ago there was a lot of discussion and thought about the maturity model of the standards track. And I remember some plenary discussions and frankly have sort of lost track. Is there anything going on there? I know we took the core V6 standards to full internet standard, but is there a push to do more of that, or?
It's not really a hot topic right now, I would say. It does come up, now and again all the time, because we have, as I said, a sort of counterintuitive maturity model. And I think there's definitely a segment of the community who still thinks there should just be one level in the standards track, as opposed to two. There used to be three, and we got rid of one of them, but now we still have two, and some people wish there were only one. I think the IPv6 is the last one that we worked really hard to bring to full standard, and the problem is bringing something to full standard is very taxing and requires a tremendous amount of effort, and a lot of times the people involved don't really see the consequent benefit, and that's why the bulk of the standards track documents are proposed standard. And I don't really see that changing anytime soon. So if you would like to make a proposal for changing the maturity levels, then we have a working group in my area, the general area, where we can go talk about that. But I haven't heard too much from the community about it lately.
So just as a data point, so I was aware of the V6 effort, right? And because I pay attention to that, what was the last spec to go full standard other than the core V6?
Oh, man, we did one in the routing area recently.
8281?
I'm sorry?
8281 in full standard?
Probably.
Yeah, I think it is. PMQ,
Probably.
Well, I remember
PMQD.
Okay, there you go.
the one that I remember was PPP, but it was a little bit while ago.
Yeah, it hasn't been very often. Yeah.
I'm sorry, it was 8201.
8201?
Yeah.
Yeah, but this was in the whole suite of
Yeah.
the IP ones.
I'll say that this is one of the areas that the IETF is a little inconsistent in, unfortunately, and trying to improve in this area. But for example, in the DNS, fully 85% of our proposed standards are still sitting in proposed standards, even things that have been operational use for 20 years. So it depends a lot on the area and the particular working group, how active they are in actually changing the status of them to reflect their operational reality.
Rüdiger Volk, Deutsche Telekom. I have been participating for something like 29 years without offering anything. I was invited once in a while. Actually, I think, Alissa, it would make a lot of sense in this room to say, yes, participation in the IETF without authoring, in particular with people who can comment on practical experience, actually is very welcome. There are some people showing up there, and it is really welcome. So people here in the room who can actually use an opportunity to visit and maybe come another time, that is really an opportunity, and I think that kind of participation of just providing relevant experience was a little bit missing from your thing. And from the classes of RFCs, of course, Sometimes we figure out that an RFC is really outdated, and we also have historics. But
Right, yeah, another detail that seems that could have been elided, but yes, thank you, and that's why we're having this track, is to encourage people to participate and in all of the many different ways. So thank you. Yeah.
Yang Yu, Facebook. The amount of time it takes for draft to become published as RFC, that can be years and many revisions. With like a particular revision can become a de facto standard, like with most implementations following that particular revision instead of like when the final RFC gets published, no one implemented the finalized RFC, but everyone just stick to the particular revision. Is this something that needs to be solved, or are there incentives for implementers to like update the implementation to the final published version of the RFC?
Yeah, so this is definitely a thing that happens. I think the incentives kind of depend on the context a little bit. So, you know, if you're not going to get anything for yourself from updating to match whatever the standard is, then you're not going to update, right? So there needs to be something that the protocol, once specified, is giving you that that incentivizes that update, right? I think the sort of more fruitful path is to try to figure out how do we avoid this situation in the first place. And that, I think, is part of what I was talking about in terms of the feedback loop between implementers and the spec writers, because ideally what we want is for these things to be developing in parallel. Granted, like you sitting with 3 of your friends can get something done a lot faster than you sitting with 1,000 of your closest friends in the IETF community trying to get consensus, and that's why the process drags sometimes. But to the extent that we can have the people who are building the core implementations also involved in the specification process, I think we maximize our chances of having the 2 things align like by the time the specification is done.
Rüdiger Volk, again, comment on that. Yes, unfortunately, the time for pushing from the idea to actually published RFC has been getting longer and longer, typically, and also unfortunately kind of the occasions where people delayed any implementation until getting to something that seems to be stable, seems to be very much on the rise. So actually I would say in the effective trade-off, having early implementations and having them kind of interfering with a final solution seems to be, in some cases, probably to be preferred over a situation where we digest about something for 10 years and then maybe nothing happens at all, or we figure out we defined crap. Kind of the running code part of our sentence kind of has been a little bit on the decline over the last 20 years, and rather get early implementations than wait for them.
Yeah, I mean, I think again it sort of depends on the area and which technology you're talking about, and we would like to do a little bit more digging on the timeliness of things. This is something that the leadership has talked about a bit. So we're hoping to get more clarity on whether it actually is taking longer or shorter. I don't think it's really obvious. I think we'll take one more and then we're gonna move on.
Sure, so Mike McBride, as an IETF working group chair, we're in the process of moving a specific draft from proposed standard to internet standard, and your comments got me thinking of reaching out to the NANA community in this process of due diligence to make sure that maybe some certain pieces of that protocol may or may not be being used and things like that. So I guess my question to you and the community is it appropriate for a working group like an IETF working group to reach out to NANA community, to email you, to specify a survey, to have you answer just a few questions as we move a draft from proposed to internet?
So the survey is an interesting idea. I mean, I think the outreach is certainly like most welcome. Like, please do that. That seems like a great idea. I think in the past, typically we've tried to bring people into whatever the working group process was. So to say, like, this is going to go to last call. Like, please chime in on this list if you have ideas. But we have had individuals who took an initiative to run small surveys or larger surveys to try to get operator feedback. So there's some precedent for doing that, and I think it's definitely feasible. So I'm happy to follow up on the specifics if you want to.
Okay, thanks.
Yeah. All right, why don't we move on?
Thank you. It works, nice. My name is Job Snyders, and I would want to share with you some of my experiences where my career in networking and the IETF were intertwined in interesting ways, and perhaps these stories will inspire younger people to participate in IETF. So not many people know this, but in my early 20s, I ran into this network service provider in the Netherlands, and they said that this MPLS problem. So that evening, I looked on Wikipedia what MPLS was, and the next day, I did a job interview with them, and I said, we got this. And somehow, I figured out their issue and remained there as a network engineer. And throughout my searches of how the internet actually worked, I was Googling for phrases of what's the next new thing after MPLS? We mastered this, we got it deployed, what's the next hottest thing? And of course, in my young interpretation of the world, that was Lisp. It had all these crazy features like v4 over v6, v6 over v4, mobility. It would reduce the routing tables. And I became very, very interested in this experiment that was going on, and I thought I should be part of that. So I dug up my first email I ever sent to the IETF, and I'll show it in my next slide. Help. This went to lisp@ietf.org. I was thinking this was a mail robot, but it turned out to be a distribution list to many people. Second attempt. And actually, this was a wonderful experience. Lisp is not the popular protocol that we envisioned it would be in the context of internet routing. But throughout this experience, I got to watch how protocol development actually worked. I got to look at excellent role models, such as Dino, the inventor of GRE, and David Meyer, who were extremely kind in guiding my young, naive mind towards productive outcomes. So totally worth it, despite Lisp not being my core job anymore. Then the second larger interaction with IETF was large PHP communities. In early 2016, this fine gentleman, Ignace, stood up at a NetNod meeting, and he explained to the audience that it's really challenging to fit 32-bit values into a 16-bit field. And we looked at it from different angles, and no matter how we tried, it would not fit. And in that meeting, I was like, you know, darn it, we can just do this. Let's go to IETF. Let's specify something that is useful, because we saw 4-byte ASN, the use of 4-byte ASNs go up, the pool of 2-byte ASNs go down, and it was clear that at some point there would be a collision between scarcity of resources and the needs of operators. And it seemed entirely feasible to pull this off. So we set out with a simple idea: let's make the BGP community just a little bit bigger. And it actually was quite a challenging process, not necessarily for IETF, but more for myself, because everybody that had a comment or objected, I took that very personal, and I added them to my enemy list. I was like, you guys, how can you not see the truth? But we railroaded it through. We called our friends who had financial spend with the big vendors like Cisco, Juniper, Nokia, Arista. We sent patches to open source projects so we could point at running code, and we developed an operational rough consensus. And this was a very interesting project because we went at it as fast as IETF essentially can go. And that meant that the RFC was published in less than a year, which is impressive. We got running code fairly quickly from the vendors a year after, and now we can finally see this feature come into the ecosystem. I checked today, there were 2,000 prefixes with large communities from 500 different ASNs. So we're kind of on track with Mr. Volk's prediction that if we go as fast as we can, in 5 years we have this. So, great experience. And my personal reflection on some of this is that perhaps at times it was not necessary to become as upset as I became at times, because some of the things are unavoidable and will happen anyway. What I also observed is that this IETF participation actually, in a positive way, helped kickstart my career. It was very interesting to be on the forefront of how things work, speak with developers, speak with architects from other networks, and at no point was there a downside to my career. So to young people, this is something to take in mind, take into consideration. If you're planning out the next 10 years, IETF can be a good way to meet people that can help you get new jobs. And I also discovered that it is perfectly possible to disagree about one project and agree about other projects. So as the years went by, I'm slowly removing people from that name and shame list on my computer and actually discovering that collaboration, in fact, often is very productive. Everybody brings unique knowledge and experiences to the table. And yes, we sometimes disagree, but that's okay. That's part of it. We should also recognize that IETF has many products, so to speak. They're not really products, but they're specs. But if we view it as a company that produces things, it has some high quality, awesome products, and there are some things that turn out to be less optimal. I'm a big fan of BGP. It's still running after all these years. It's still being extended. We're still fine-tuning it. It's still meeting our operational needs. And it's a very, very impressive effort. But we also produced other protocols where different choices were made at times. And this is the IETF. It's multifaceted. We cannot say the IETF is good or the IETF is bad. The IETF is this sort of engine that churns through things, and garbage in means garbage out. And that's how the process is designed. Now, if I look at my future trajectory, in recognizing that we ourselves have a role in IETF and that we cannot point blame at IETF for saying why were large communities not invented earlier, the only reason those things didn't happen earlier or they didn't happen conforming to your requirements is perhaps because of lack of participation. So I joined the board, became a chair of the GROW working group, which is the nicest working group we have, volunteered for the NomCom. The NomCom is the group that will help appoint or influence appointments of the IETF leadership. So in this way, we have a capacity to steer where the organization actually is going. And from time to time, people come to me and say, hey, I want to go to an IETF meeting. Can I tag along as your mentee? Will you introduce me to people? Will you explain processes and include me in this community? And this is what I'm currently doing. I'm happy with those developments, and I would strongly encourage others to follow suit and consider where it is they themselves can participate. What are the itches you have in your daily operations where you think, hey, if we tune this thing just a little bit to the left, everything comes better. And that's where IETF can be helpful and be fun and enjoyable. This brings me to the end of my slides. If you have questions, comments, please approach me now or email me later. No questions? Everybody joined the GROW working group? Thank you for your time.
Ron, I think you're next, Ron.
Who's next?
I think you are, Ron.
Oh, I am, okay. Hi, I'm Ron Bonica, and I'd like to talk a little bit about the INT working group. Several years ago, I was on the IESG, was the AD for the Ops and Management Working Group, and I remember the INT AD talking about the INT area charter. The fellow stood up in front of the IESG and said, "The INT area's charter is to make the internet more better, more good." And I thought about that for a while, and in a way he was right, and in a way he was wrong. The INT area has a formal charter here, and it has directors, Suresh Krishnan and Aaron Vink. It owns the forwarding plane. It owns IPv4, taken care of in the INT area working group. It owns IPv6 maintenance, taken care of in the 6-man working group. It also owns a couple of protocols that are absolutely essential to the operation of the internet, application layer protocols that are absolutely essential to the operation of the internet. I'm thinking of DNS, I'm thinking of DHCP, I'm thinking of NTP. Without those, there would be no functional internet. It also owns some other protocols like Softwire and a few others around the edges. Informal charter, I guess I just went over that in the last slide. There are a bunch of active working groups, some that I haven't mentioned, like IPv6 over networks of resource-constrained nodes, 6LoW, 6TISH. But most of them are around things like DNS, DHCP, the things that are absolutely essential. I'll go first make a disclaimer. The INT area covers a huge problem space. Each part of the problem space is an area of interest for a unique community. There's a wireline, mobile line, there are wireline, mobile, cloud, and enterprise operators, constrained network operators, special purpose operators like vehicular networks. And the following slides introduce a couple working groups. One of them is 6-man. It's responsible for IPv6 maintenance. Right now they're working on IPv6 data plane for segment routing. There are a couple drafts in there. Extension header limits, MTU discovery. You'll also find interesting debates in there about extensions to Slack, occasionally even interactions between Slack and DHCP. There's the dynamic host configuration working group. It is in charge of things like DHCP v6 and everything around that. DNS private exchange, deprive. DNS Prive Working Group develops mechanisms to provide confidentiality in DNS transactions in order to address concerns surrounding pervasive monitoring. An interesting one too. People in this area, to operators. Also HomeNet. They talk about requirements for home networking, networks that are more than a trivial home network, more than a few routers behind, a few hosts behind a router. They also spun off a routing area working group called Babel. And then there's the INT area working group. The INT area working group is kind of a catch-all. It takes care of operational architectural advice, things like fragmentation, considered fragile, IP tunnels in the internet architecture. New encapsulations like GU, although there's another working group in routing, NVO3, that also talks about encapsulations. And new OAM and mechanisms, things like ICMP probe, ICMP extensions for unnumbered interfaces. This has been a very small overview of the INT area, but I'd like to make a general comment about the internet area. When a network operator, I'm going to compete with Ignas for just a second to get your attention. When a network operator looks at the IETF and decides what area to become involved in, it's very natural for him to become involved in the ops and management area. Of course, I'm an operator, the ops area is the place to be. That's how I first became involved in the IETF, in the ops and management area, and then over time I was director of the ops and management area for some number of years. As it turns out, you folks have the best expertise to inform and direct the INT area. You understand how protocols actually operate, how they scale, how they interact with each other, how they fail. Because of that, your input is really, really important to to 6-man, to the DNS, for those of you who are DNS operators, to the DNS working groups, to the dynamic host configuration working groups. So please do take a look at the INT area when you decide which working groups to monitor and where to review drafts. Any questions? Well, thanks.
Hello there. I'm Ignas Bagdonas, and I'm one of the area directors in IETF, and my direct responsibility is in the operations and management area. So a quick overview of what is happening there and how that is relevant or possibly relevant and interesting to what you are doing here, and at the same time a call for help of feedback and information of what you see in your field, what possibly is missing or wrong, and how could you provide that information into the IETF. So operations area, while it has one name, in fact, those are more like 2 sub-areas in that. One that deals with operational aspects and the other that deals with manageability aspects. And I wouldn't say that there is a lot of intersection between those 2 parts. Quickly looking into what's there, ops area deals overall ops area deals with the deployment aspects of the IETF deliverables. And it is about the usage of certain groups of protocols, developing best practices or recommendations of how to deal with those protocols, how to deploy them. And then a large part of the work is dedicated to the evolution of the network manageability. One important note to remember, and this is what I personally hear quite often from the people who are new to the IETF, is why IETF doesn't work on standardizing this particular architecture for this deployment model or something along those lines. IETF as an organization is good at working on components and technologies, basically fragments. And it's not necessarily the right place for dealing with how do you bind those components together and build a solution. One part of that is that a lot of this is dependent on vendors and vendor implementations, and IETF is not a place which controls the vendors. The other aspect is that it is you as an operator, or in an architect role within an operator, you take those components and provided that you have enough information about how those components work, it is you who are building that end-to-end solution. And let's look realistically. Each of yours, one of your networks is different than the others, and therefore it would be difficult to try to define some sort of kind of general best practices or architectural recommendations that would be applicable in a more general sense. So what's inside of the ops area? A very brief overview, and then if you are interested, you might take a more detailed look following the links provided. Autonomic networking, ANIMA, that's an area which probably produces certain protocols and specifications which might look rather, say, fascinating. Imagine a situation you take the box, unbox the router, plug the power in, plug the cable into matching color socket, and after some time that router boots up and it is visible in your network management systems and is becoming more or less operational. How do you bootstrap such a network autonomously without operator touching that? Doing the secure bootstrap, how do you validate that the device which you are booting is actually the device which you are supposed to be and not something like pretending it to be and things like that? Zero-touch provisioning, how you enable new devices operating in the network without touching those. Benchmarking, looking at the methodology, not the benchmarking and not looking into which vendor has the fastest router, but that's about the methodology of how do you measure the things. Few of the working groups like DIME and RADEX, they are dedicated to the maintenance of important protocols which have been widely deployed and still are deployed, diameter and radius. DNS operations, dealing with the topics related to the deployment and running operational aspects of the DNS infrastructure. The most important working group of the whole IETF is in Ops area. That's where the discussions about the topics related to the operation of a global routing in infrastructure. The deployment aspects of multicast, MBOND, deriving its name from MBONE, an experiment of several decades ago. Now, two working groups which are both active and personally for me very interesting. NetConf and NetMod. This is where the evolution of the network manageability happens, and we will talk about that in a short while. The Ops area working group is a kind of a catch-all filter for all loose ends, which doesn't mean unimportant topics or boring topics, but small fragmented topics which don't have any other home related to operations. And one notable topic which is being discussed there is the developments around the protocols related for the telemetry. Both mechanisms of what do you need to export and how, and actually encodings and things like that. Operational security aspects, filtering, black holing, how does that work, what are the recommendations and practices. Now, CIDR operations, this is kind of a, as IDR has grown, CIDR has CIDR Ops. It's a working group which deals with the operational and deployment aspects of CIDR. And V6 operations, the working group dedicated for topics related to IPv6 operational and manageability aspects. Now, moving to the one part of the other part of the Ops area, the manageability part. Many of you probably are running networks here, and many of you are familiar with the pain points which are there. Things like SNMP command line, automation scripts, and topics like that. The problem space of running the network is frequently overlooked from the both vendors and the standards perspective, in the sense that we have delivered you this nice feature, it works, it interoperates, that's fine, the problem is solved. The management aspect of that feature is frequently overlooked and left aside. Basically, the parity of feature management and the feature itself, there's quite a big gap in that. And if we are looking from a practical perspective, that's a pain point. If I have a feature but I cannot manage that, that feature is more or less useless for me from a practical point of view. Looking into the manageability aspects, we have several large areas here. The configuration itself of a device, the state or how and in what way the device operates, and the statistics and operational data related to that. If you look at many of today's practical deployments, or if you look at the previous IETF architectures based on SNMP or on some other telemetry protocols, Generally, those technologies cover one of these domains. They don't necessarily cover all of them. However, what I need, if I look from a practical perspective, if I configure something, that's one. But I would like to know if the functionality that I configured is actually operational, and if it is operational, at what parameters it is running. A practical example, I configure a BGP session. The fact that I send out the command to the device, establish BGP session with that address, does not mean that the session is there. And if I ask for a BGP session with the particular keep alive interval, it does not necessarily mean that it will be that keep alive interval, because the other side might disagree with what I have asked for the box to do. Therefore, we have three different views of the same configuration information, and that needs to be correlated somehow. Now, looking into the path that IETF is taking here, it's a move away from configuration protocol-based mechanism into a schema-based mechanism. What is less important is actual protocol which you talk to the device. The more important aspect is how do you structure the configuration information. And looking into the SNMP days, SNMP sees the world as a table, as a one-dimensional table. And if you take, if you look from a practical perspective, in networking there are many structures and entities which are well represented in other ways, like trees, sequences, and things like that. And it's not so easy to represent that in the SNMP way. So what is happening in IETF in a more practical terms? Two large areas of work. One is the definition of the configuration language, it's called YANG, which defines the schema of the information which is needed to configure the device. It's not a configuration language, it's not something that you talk to the router, it's something that describes the information which eventually will get sent to the network device for changing its state. The other part corresponding to this is transport protocols, encodings, and mechanics of how that is being sent and interpreted. What this gives for you as an operator, you may have multiple channels into and out of the device, not necessarily the same channels. But those channels might be using the same data representation, the same schema structure for sending out, say, intent or commands to the device and getting the results out of it and getting the notification in forms of like messages or telemetry data out of the device. And then you have the ability to correlate all of the three of them. And eventually, if we are looking at the longer-term evolution of manageability, there's a trend of moving away from what is basically what you do with the device, what commands you send to the element, to the construct of you send the intent saying that I want, for example, functionality with these parameters. Now your device, you are smart, go and implement that. Three things are needed for this to work practically and efficiently. Modeling, the schemas and the definitions of all of this configuration data. Tooling, this model of approach doesn't assume that there is a live operator on the other end. There's a software component there. And the education, explaining how this works and how this practically can be used. So in summary, what is happening in the ops area is related to how you as the operators community interact with the network and the network devices. Arguably, the biggest amount of work happening there is related to configuration modeling, basically describing the functionality and features in a way of model that can be used for configuring the devices and networks. Now, this is not a new topic. IETF has been working for that for around 15 years, and the problematic aspect of that is acceptance, a practical acceptance of that in the industry. it's not as good as it could have been. And that's a question of education, that's a question of explaining how those technology components can be used. Another important aspect that IETF frequently gets caught with is to try to build an absolutely perfect and all-covering solution, and at once. Arguably, that is not needed. While it might be a nice exercise, but having something which covers the dominant part of the functionality and ship that fast is the model that is needed. And that's where your input as the operators and users of this would be very helpful. Since trying to define the priorities of the technology components which are needed for you, and define, say, the list which covers 80% or some other majority part of your functionality, and then define the actual components from IETF side and ship it. That's basically it about the operational part. I have been talking with quite a few of you offline here and also at the previous meetings about all these young and configuration parts. I would be very happy to continue this discussion, basically to get the input either right now or after all of this. This is something where you certainly can start participating and providing the feedback into the IETF, and this might be a rather easy and simple way of entering there. It's you who are running the things, and you understand what is important and what is not so important from the operational perspective. This type of insight does not necessarily readily exist in the IETF community. And that is one of the reasons why we have the situation where the manageability, say, proposals, manageability architectures coming out of the IETF take a really long time in the industry to get accepted. That's it from my side for now. Thank you.
Questions?
So later, when the slides get posted, you'll see a routing area overview similar to the one that Ignis gave for operations and management and that Ron gave for the internet area. But unfortunately, our speaker couldn't be with us. So if you're interested in the routing area overview, check out the slides later, and they will have pointers to many of the relevant working groups that people might be interested in and want to check out. And now we get to talk about encrypted DNS.
No, I think we need a lot of question and answer period on that. And so, hi, I'm Tail, and when Alissa asked me to come up and give you an update on the encrypted DNS happenings in the IETF, I was like, oh good, that's so much easier than talking about everything that's happening in the DNS. It's gonna be no problem. So basically, when we look into when the first actions were taken around encrypting DNS transactions, back in May of 2016, we put out an RFC for specifying how we could do DNS query and response between a client and resolver using TLS. And then in October of 2018, a couple of years later, we finally put out an RFC on how we could do DNS queries over HTTPS, which of course is still over TLS, but then encrypted in the HTTP protocol. Earlier this year, this summer, we had a BOF on talking about, okay, well, let's have a further look at how this changes the application landscape with regard to DNS, but we weren't planning on starting a working group then. And so next month, we're going to have a Birds of a Feather session that's looking towards how can we make a working group that specifically addresses this interaction between applications and the DNS. So, pretty straightforward stuff, not much to see here. I'm all done. I think we get a whole hour back, so go take some time off between beer and gear. No? Tried. I am going to try to give you, however, a nearly neutral status report. I'm not evangelizing myself for the adoption of any particular technology. Inevitably, because I'm talking about the reason the IETF is working on it, some of this might sound like advocacy, but it isn't. I personally, even though I'm the co-chair of the DOE working group, I don't agree with everything that's happened in the space myself. I will admit my bias towards wanting to see encrypted DNS, but I don't have a passion toward a particular technology for achieving that. And notably also, my employer has taken no position on the whole issue. The IETF leadership, the IESG and the IAB, have taken, while broadly they're moving in one direction, there's still a non-trivial amount of disagreement among the leadership about what's happened and what should happen next. Also, notably, even though there are a lot of position papers being put out by different groups about either how it's the worst thing ever to happen to the internet or is going to be the savior of privacy on the internet, external communities don't even agree. There are, for example, in the specific area of DOE, there are ISPs lining up on both sides of the issue. There are also other external sectors. For example, I have talked to some people in the European financial sector who are very much in favor of it, while there are, of course, other enterprises that are very much against it. So it's a complicated area that's still with a lot to be talked about. And as I said, some of this talk might end up sounding like advocacy, but really the devil is going to be in the details. So how did we get here that we're even talking about DOT and DOE and encrypted DNS? Well, we have a ways back to go for the full context. 4 billion years ago is when life appeared on Earth. Now, I could go back to the Big Bang Theory, but we can skip a little bit. Then, suddenly, there were dinosaurs.
Still are.
Yeah. Just because you're the young one in the IETF doesn't mean that you have to be that way, young man. And then about 200,000 years ago, anatomically modern human beings appeared. Basically, we think this caveman thing of, oh, they were all so dumb, but they were basically us. And so that's when things got really complicated. Now, I am going to fast forward a bit. I wanted to take some time to kind of look at the broad cultural milestones, as Paul did with the Treaty of Westphalia, talking about how humanity has kind of grappled with the issue of codifying and controlling good versus evil, and trying to identify where the error bars should be on that. But we're going to put in 200,000 years of whooshing noises and actually get into the 2000s, where the IETF published RFC 3514, which is affectionately known as the evil bit. Steve Bellovin actually tried to, though it was an April Fool's RFC, Steve actually really articulated a very interesting aspect of trying to manage traffic on the internet, is that we don't have any really good way of determining what's good traffic and what's bad traffic, what is evil and harming us and what is acceptable. One thing I noticed when I was just looking up the reference for it, it actually has errata that was published last year. So it's good to see that the IETF is staying on top of this. So I bet you thought at first that I was going to go for Edward Snowden. Of course it has to come up. This was a very significant cultural milestone in the IETF. When Snowden's leaks about the Five Eyes program and how multiple nations were cooperating for global surveillance of the internet. That led later that year, in November, into the IETF Tech Plenary, where it was a significant issue of discussion and kind of kicked off the IETF response to figuring out, well, now that we know that this theoretical thing is actually a practical thing that's happening, and we're responsible for the health and safety of the internet, what should we do about it? So that led in May 2014 to RFC 7258. Many of you may be familiar with it. It made the bold declaration that pervasive monitoring is an attack. What's interesting about this particular document is that the IETF tries really hard to stay in its lane as far as being a technical standards-focused organization. And even this RFC, while short, is written very much focused on this is here's the technical problem with pervasive monitoring with regard to the rest of the internet. The IETF, members of the IETF very often claim we don't do policy, but inevitably the technology that we produce kind of greases the skids for policy in one direction or another. And this particular document, although it doesn't, I think, use the word policy anywhere in it, is very much a policy position paper about saying, here is our intention for handling pervasive monitoring on the internet. Basically, we want to secure it as well as possible. And it directly articulated the concept that was previously in that April Fool's RFC, and that we can't really tell good versus evil traffic. And so while there might be benign reasons for doing this kind of monitoring, the system as a whole can't tell, and so we have to protect the system. And then as a result of that RFC, the IETF started working in many different areas about how to lock down protocols and or evolve them into secure versions of their previous selves. And in October of 2014, the Deprive Working Group was chartered, as previously mentioned. The focus of this was to provide confidentiality for DNS communication. It's had several different work outputs. You may have heard of some of them, like QNAME minimization and other methods, but notably for the encrypted DNS part of things, it published RFCs 7858 and 8094. This was for basically using DNS over either a TCP TLS connection or a UDP DTLS connection. What's notable about this is following the publication of those documents, DOT has been implemented, that's DNS over TLS, the TCP version, has been implemented in a few different areas, but it sees almost no operational use. I think Jared is still here, and he just recently told me that he can count on one hand the number of DOT queries he's seen to his server that implements it. And DTLS, though, you know, little bit of context. Most of you are familiar with the fact that DNS, normally we try to have very, very lightweight in order to have servers be able to handle a really huge volume of queries in a pretty easy way. Throwing cryptography on top of it is not so amenable to those goals of light and fast. DTLS was trying to find the sweet spot. Well, between doing UDP and TLS, can we somehow make it more efficient? But nonetheless, I'm not aware of it being used even experimentally. Following the publication of those documents, Deprive was rechartered, and what it's trying to do there now, because I think I mentioned earlier that the initial effort was to secure the channel of communication between the client and its resolver, or from the client stub resolver to the full service resolver. Many of you may recall Paul's diagram. I'm sorry I didn't include one about the entire architecture of the DNS. One of the things, though, that wasn't really worked on because it's a different class of problem is how do we secure the channel between full service recursive resolvers and the authoritative servers that are providing the real answers. And in this context, I also mentioned that there's often been confusion about the type of security that encrypting the channel would provide, and some people think that it would obviate DNSSEC, and oh great, you don't have to worry about DNSSEC anymore. DOT and DOE provide confidentiality on the channel. They don't provide any sort of data authentication. And so DNSSEC and its design goals are still a really important part of the overall picture. But in any event, this trying to secure the authoritative channel is now active work effort going on within the Deprive working group. And although it's not currently, Christian, who I don't think I've seen here, Christian Huitema is also proposed how DNS could be done over QUIC, which would be likely to see a little bit better adoption than DNS over DTLS. But so far that's been handled in the QUIC working group rather than the Deprive. Then, September 2017, just over 2 years ago, we spun up the DOE working group. It had a very limited charter scope. It was intended partly to be a new model for a pop-up working group. It really, the area directors thought this is going to be awesome. We have such a narrowly focused charter that we will publish one document, just how you would end up tunneling a DNS query through the HTTP protocol wrapped in TLS. And then we can all just go home, shut down the working group, and leave it to other people to figure out the other parts of the overall system. DOE still exists. It was very much focused on just those technical aspects of tunneling DNS requests in HTTPS and how those get encapsulated. Discovery mechanisms were actually left to be in scope, but were not pursued yet because it quickly got into very difficult technical questions, and they were largely orthogonal just to how to achieve the very easy and achievable goal of tunneling. So we published RFC 8484, and this was the DOE protocol itself that had to do DNS queries over HTTPS, and it was met with universal acclaim. No, wait, that's not right. So the group itself is currently dormant. It's awaiting IETF consensus about how we proceed in the space, how we can tackle our next issues. So this summer, we started trying to look at that. We had this applications doing DNS BOF to look at what the other architectural implementations were of the way that applications in general, not just web browsers, were interfacing with the DNS. What would this mean to have more applications bypassing the system resolver and all the different ways that the system interacts? what possible work effort could we do here? Because the publication of DOE had triggered this broader discussion of the whole client resolver architecture. And there were some vendor experiments, and you probably heard of one because it generated most of the flames, the Mozilla and Cloudflare experiment. And it provoked strong reaction, and so this is another reason we're having this BOF, because some had declared the death of the DNS, and in the 7 stages of grief, we proceeded pretty rapidly into the anger and bargaining stage. The BOF was seeking to, figure out, well, okay, there's clearly a lot of policy issues here that the IETF can't really do anything about, but there's also technical work. Can we hone in on what technical work might be achievable for us to move forward on? And that brings us up to date with everything that's happened so far.
This is actually in 2019, right?
Oh, did I say the? Oh, June, yeah, this happened just this past summer. Sorry, typo on the slide. And so I know many of you wondered, well, why did the IETF adopt DOE? You may recall from Monday the phrase being said, the IESG and the IAB should have been the adults in the room. And well, I actually happen to agree with a lot of things that were said in that talk, but I thought that was an unnecessary slam. The process for bringing new work to the IETF was followed. There was a very identifiable, technically achievable goal. While the proponents may have had multiple motivations, in fact, I'm sure that they had multiple motivations, at least some of those motivations were consistent with the things that the IETF was trying to achieve. And the general idea of it was already in the wild. It's not that DNS over HTTP clear text had been not already happening. There were several different implementations of it happening. And so it's worth noting, as Alissa pointed out, that the IETF as a voluntary standards organization doesn't have a lot of power in this area. And just because the IETF says, no, you're not going to do that, it doesn't mean it doesn't happen. Other people are still going to work on it. They had been working on it even without the IETF. So one benefit of the IETF working on it is that the process tends to bring about better engineering results, right? We tend to, when we have multiple people from multiple disciplines reviewing a protocol, then the output from the working group tends to be better, more implementable than it would have been otherwise. And in fact, DOE went through the same thing. The first draft of DOE to the final draft of DOE had multiple meaningful technical differences that improved upon the protocol. And so the thing to remember here is that DNS over TLS and DNS over HTTPS, they're only providing an encrypted channel. They don't actually fundamentally change anything about the DNS. There are some deployment models, like the Mozilla Cloudflare experiment, that do significantly change the DNS architecture, but they're not intrinsic to the protocol. And I'm not trying to minimize the significance of that. They could represent a significant and, for some particular business models and operational needs, disruptive operational change to the existing DNS architecture. So that's all relevant, but it's really important within the context of the work the IETF does to separate our understanding of the way a protocol works and from the different operational ways in which it can be handled. So now that we're here, what's next? Well, the IETF itself is going to continue to embrace the multi-stakeholder process. For those of you who are unfamiliar with this principle of multi-stakeholderism that's involved in many of our different organizations, we try to bring in people from all communities that are affected by this, whether it be operators or enterprises or developers, political groups. Everybody is really welcome in the process. People who are for it, people who are against it. It's important to have all of that input in order to move forward to achieve whatever kind of consensus may be possible. To that end, we're having the application behavior considering DNS BOF in a few weeks in Singapore, where we're going to be planning the next steps for the technical standards, probably spinning up a working group on it. And so we're going to now tackle issues like resolver discovery and how you could express the policies of different resolvers to characterize them. And then so that in an environment where you had multiple resolver choice, we could understand how best to guide those choices and how they're used, and provide other general operational recommendations, including but not limited to, the deployment model issue. And we're also going to have to make clear the IETF itself through perhaps an informational RFC or some other document, what the IETF can't address as a standards organization, the actual policy issues that are completely separate from this. And one of the things that's really important to note there is that the deployment choices that individual companies make is really outside the scope of the IETF. It doesn't have control over it. We can try and guide things with our suggestions, but ultimately it's not the IETF making those final decisions. And so really what I most want to emphasize that if the outcome of all of this process around encrypted DNS is important to you, please participate. It's really important. There are actually now also, in addition to the work that's happening within the IETF, there are a couple of associated organizations that are spun up on advocacy or against. And your input and contributions will really be can have a meaningful impact on how the rest of the process plays out. And I believe that was my last slide. Yes. Thank you.
Success.
We're done. Beer and gear. I don't know if that's true, but I mean, really, no questions?
That's a huge milestone.
Okay.
You gave a whole talk about encrypted DNS and you got no questions.
Just so stunned. It's still
there we go.
It's still considering how dinosaurs.
Thank you. We couldn't let that happen,
went away.
Chris.
It's not a question about DNS. It's a question about IETF. So Tail said early on in his talk that you did this thing. You went to the IETF to do this work. For this particular presentation, you had some opinions, but no particular slant you wanted to give to it. And you said your employer didn't either. So is this because at the IETF?
Right. So do you want to comment on that, Alissa? Or?
Sorry, your question is about the influence of employers at the IETF?
That you represent yourself, not your employer, yes.
Right.
Yes.
So,
Go ahead. Yeah.
Right. So an important principle of the IETF is that individuals represent themselves. And generally speaking, unlike some other organizations, including NANOG and RIPE, for example, generally you don't affiliate yourself explicitly when you stand up to make a comment at the microphone. The note well of the IETF includes a number of guidelines for your participation, and one of the aspects of this is that individuals represent themselves and not their companies. On a personal opinion, this is, of course, a noble statement of ideal, but on the other hand, people know who you work for and will kind of understand, how you might be advocating for the position of your employer. And so it's not that that's never an issue, but the default assumption among people working in the IETF is that you are standing principally for your own views, and they don't necessarily represent any cleared view that your employer may have held.
It's liberating. I get to go to the microphone and argue with my boss.
Yeah, and I think one of the aspects of that, speaking as a person, is we are keeping out of the arguments the weight of the organization.
Right.
I think I have seen a couple of occasions where someone came in who was not really familiar and was pumping up and saying, well, okay, I'm representing this huge influential party, and, well, okay.
Right.
Doesn't count.
Unlike some other paid organizations, paid standards bodies that you may be familiar with, there's a lot of latitude within the IETF. I kind of hate to use the word meritocracy because it's been politicized itself over the past couple of years. But being able to get things done doesn't stand on whose employer's name is on your badge, right? Like when it comes to people getting up to the microphone, there are independent consultants whose arguments carry just as much weight as an engineer from Apple or Cisco would. And I think that's part of what makes it a better process. It's really welcoming to everybody for the most part. I think most participants are not concerned who you work for, it's just how good your ideas are.
In fact, we have a motto, we reject, I forget what it is, we reject kings, experts, and and something else.
Right.
We honor rough.
We reject experts.
Oh, presidents we reject. Okay.
That explains a lot.
Well, we reject some
Voting,
important people.
yeah.
We respect rough consensus and running code.
Right, which is, again, a noble ideal that is sometimes thwarted by the realities of interpersonal conflict. But, but that is the goal, is that we're looking for the best ideas no matter who brings them.
It also means that there can never really be a NANOC representative to the IETF. It means that we as individual operators need to engage in the process and contribute arguments for or against. But there can never be, and I as an individual represent the views of this room. Not only would that individual never get authority from this group, but in IETF context, that part of the footer in the email would just be ignored.
David Belson. For the multi-stakeholder process, do you go out and solicit input in some cases? So like Dale, you were talking about with DOH, there's the various types of organizations that it may impact. So if there's no representation, say, from governments or certain types of governments, do you go out and solicit input and participation from them, or is it sort of like you didn't show up, so you don't get to complain about it later?
So given, again, kind of the structure where...
But they know to show up.
Right, so given kind of the structure, a lot of that relies on either a working group level or individual initiative level to bring in the people who are involved. It is often desired, but sometimes it just doesn't get thought about. But many times we realize that we're talking through an area where, for example, some technical expertise might be necessary, say in the area of internationalization, and that expertise is not available. And when people are aware of that, then that's the much more common way that we see people reaching out and pulling in the expertise that's needed. But it can be a lot harder to bring in other advocacy groups or that are, when I say advocacy, for their own particular position, it can be a lot harder to get those people involved.
We have done some specific outreach where we knew there was a connection, like around emergency services and like large-scale broadband mapping, right? We already had some interest from some regulators in some countries, and we knew that there were others that were generally working in the space, and so we did like proactive outreach to say, hey, Ofcom, we think you're interested in this, don't you want to come? Same thing we did recently with a new initiative, which is also going to be a birds of a feather session at the next IETF meeting around web packaging, which is this like signed exchanges, we can bundle web resources together. We know that this is of high relevance to content producers and publishers, which is not really a constituency that tends to show up in the IETF. So we've had a workshop and proactively said, hey, New York Times, don't you want to come tell us what you think about this? Or somebody from the New York Times. So in particular contexts, sometimes we do targeted outreach.
And I'll also note really quickly, this right here is outreach.
Correct.
So if you find it useful for at least to have periodic, maybe annually updates on what's going on in the IETF, please reflect that in your surveys, that you'd like to see it happen again.
Yeah, that's actually a really good point. We are always debating, like, how often does this yield anything? And we don't have good data ourselves. So putting feedback into the survey would be great. Also, if you have other communities that you're a part of where you feel like, hey, they would really benefit from this kind of session or something, would love to hear about that, because several of us have gone around and to some of the RIR meetings and some of the other operators groups, but we're always open to more suggestions.
Tony Tauber again. Just in this vein of interacting with other groups, I mean, I think there is some, or has been at different times, like some sort of official liaison things with some other standards bodies like IEEE or W3C maybe, or some of these. I don't know if it's worth talking about, or just sort of say it does happen from time to time.
Yeah. So for SDOs, we have people who are designated as our liaison representatives, and they have the same thing in reverse. So we have a person who's our liaison to 3GPP, and 3GPP has a person who's their liaison to us. And we keep in touch with those people. Sometimes we send formal liaison statements back and forth when something needs to be communicated about a document that you're working on, or what have you. With an organization that where we have a lot of overlap, like IEEE, we actually have like a bunch of their leadership and a bunch of our leadership who stay in touch. So it just depends on like how high touch the relationship should be, depending on the amount of work that's joint. But we don't tend to do it with anything other than SDOs. So we haven't really done it with operator groups, for example.
Hi, James Shank with Team Cymru. A question that I had about the work of the IETF in general. Part of the conversation described things as innovative or paving a way, and part of it was presented as reactive. So would you characterize the work of the IETF in general as reactive to something that is already in existence in some capacity and needs to be moved towards a standard? Or would you characterize it in general as innovative, or is it a mix of the two?
It's a mix.
Yeah.
Like SSH and NTP were formed outside IETF, but later brought in because IETF is an excellent publication platform for protocol specifications. But there's also been tons of original work in the routing areas or IP.
DNS itself started in the IETF back in the 80s.
Yeah, which was, of course, an IETF looking very different from what we have today. For the real research and innovation, there is also the parallel IRTF. So kind of the task of the IETF is to tackle stuff where we know we can get a result, while researchers, of course, have the latitude for, well, okay, if some research does not provide a result, we actually still have gained knowledge, and that's valuable there. But
any other questions? Great. Well, thank you very much.
Thank you.